All right. I forgot to auto start on YouTube, but I think we should be live now, or about live now. So I'll say what I said before I forgot to turn on YouTube. Check the description for time codes if you want to skip around. Usually I'll take a couple minutes to get going here, and then yeah, just we won't get started immediately, and the stream tends to be long, so check the time codes. But Vin is in the picture, and she doesn't necessarily like me talking, so she's like wondering what I'm doing. I might have to let her out. We'll see. Not every day Vin's on the stream with us. We'll see how long she lasts. So let me say some hellos. I even checked my my list, and I forgot to do that. But yeah, we'll take some time to say hellos and get things going. Hello Thomas. Hello Mark. Hello Jed. Top-notch cat footage. That's what we strive for here at Adafruit. Top-notch engineering cat footage. Hello Beata. Double the cats. You can see she's deciding whether she's going to stay or not. She wanted to be on my lap, and I ignored her, so she went to go sleep with her brother instead. Hello Hams Labs. Hello Tammy. Hello Foamy Guy. Hello Anecdata. Hello Keith. Hello DCD. Hello Patrick. Hello Deshipu. Should I just do 2 hours of cats? Hello Adib. Hello X Micron. Hello 2231 Puppy. Hello Andrew R. from Cornwall. Hey Paul. Thanks everybody for joining. These two cats woke us up last night fighting. You wouldn't know they would fight, but they do as well. They sleep together and they fight as well. Yeah, so I'm a little tired, but that's going to be my MO this year, I think. Because if you don't know, we're expecting a human being in this family that will keep us up at all times of night. So these cats are in for something. We're all in for something. Abadus, say that right? Abadus, maybe? All right. Yes, please. 2 hours of cats equals a happy forever. Well, we'll see how long we have 2 cats. She keeps looking at me. All right, let's do housekeeping. Let's get the show on the road. Like I said, I'm a little tired. I've been trying to get myself into focus mode, so we might actually dive into some code here today, which I'm looking forward to. All right, maybe we'll switch off cats here, even though it's up in the corner still. Do the cats know any Python? I don't think so. They're good at finding treats, I'll tell you that much. Okay, so hello everyone. My name is Scott, and I work for Adafruit on CircuitPython. Adafruit is an open source hardware and software company based out of New York City, but I work remotely for them here in Seattle from my house. And CircuitPython is a version of Python which is a really easy programming language to get into and learn. But we designed it for microcontrollers, which are little inexpensive computers like this one. So underneath this metal cover, there's a small computer chip that can do Wi-Fi and BLE and run CircuitPython. It does USB as well. So if you want to support me and Adafruit, who pays me, please go to adafruit.com, purchase some hardware there. Yeah, thank you so much in advance for doing that. I should also introduce, we have both cats here, so you can see there's Vin and Spook. Vin is the one on top. And she's got like a smaller patch of brown than her brother, who has like brown onto his ears. They're siblings. And they have a love-hate relationship. Yeah, so that's me and the cats and Adafruit. If you want to chat with me and a bunch of others, we do have an Adafruit Discord server, which everyone is welcome to join by going to the URL adafru.it/discord, and that will pop you in, and that chat lasts all week long, all weekend long. So that's a great resource for folks to get help with CircuitPython and other Adafruit hardware stuff. So I highly recommend folks join there. This is a deep dive. It happens every week for at least the next few more weeks. I'm not exactly sure, so I'm not exactly sure when I'm going to stop streaming. Foamy Guy's already said that he'd like to take the slot over, so expect to see some streams in this time slot even when I've finished doing them. They're normally Fridays at 2 p.m. Pacific, which is now-ish. And they typically go for 2 hours or more. So I'm kind of tired, so we'll see. She got mad. She is currently showing her frustration out on the DigiKey box that I have on the floor here. She really likes the cardboard paper packaging that they have. Yeah, so obviously this is a casual stream. We've got 2 hours to hang out and work on some stuff. If you have questions about CircuitPython or electronics, I'll do my best to answer them, but there's also a lot of knowledgeable folks that typically are in the chat. So if you have questions, feel free to ask those in the chats. I'm following primarily the YouTube and the Discord chats, but I do have like LinkedIn and Twitch via the restream as well. Last up, all notes are available on GitHub. There's a github.com/adafruit/deep-dive-notes. And that is where we kind of collect all of the notes that David creates for the streams. Super helpful. So thank you to David. And then Ask Patrick W does a good job curating everything there. So if you check out that repo, you can actually search it to find a topic and then actually click a link to jump right into the time code of the relevant video about that topic. So it's a great resource, and thank you again to Patrick and David for putting that together. Let's say a few more hellos, and then I think I might have to kick this cat out because she's threatening this DigiKey box. Hello, Unexpected Maker. Thank you for posting the link at Ask Patrick W. Sounds like Ham's Lab starts a new job, so congratulations. Congratulations on the new gig. Hello, PupDev22, which I think is 2231 Puppy on YouTube. So, yeah. Patrick says, I fix issues with the GitHub Actions to make that work as a hobby. Mark says, early question, did you ever cover how the compiler works in CircuitPython on one of these deep dives? I don't think so. I saw your question about the linker. Is that what you're thinking? I'm going to take my mic off here and just let Vin out, and then we'll get back to it. Yeah, you want to go up? Bad Abby's asking Unexpected Maker when Unexpected Maker's S3 boards will be available. Maybe I should stand. I adjusted my desk a little bit, although that puts me a little higher. I like it a little bit higher when I'm standing, so I'll do it for a little while. Abadus is getting some Feather RP2040s, which is awesome. What do the cats think of that paper wrapper that comes in the DigiKey boxes? Vin really likes to tear it up and shred it even more. Hello, Kinger North, and hello, Bruce S. on YouTube. Unexpected Maker says, later today. I released them to patrons yesterday and giving them some time to purchase first. That's a great perk. That's a great idea, Unexpected Maker. Giving your patrons an early access to buy new hardware. It's a good idea. Gary T says, cool chair, thank you. It's a weird, I don't know if you can see the seat is weird too. I like it and I don't like it. It's not meant to be super comfortable. It's meant to be something that you want to like not sit on for hours. It's something that you're supposed to like want to sit on in a bunch of different ways. So I think it does fit that bill. Mark says, did you see that Zephyr now has support for the RP2040? I did not. I'm not surprised. Mark says, looking from both points of view, linker was for the actual linking of the CircuitPython core and just general knowledge. The compiler for more how the internal Python compiler works, to save maybe some time going through the 3,000 lines of compiler.c code. I don't necessarily recommend you worry about how compiler.c works, honestly. Unless you're adding a Python feature that's like syntax related, you could just ignore it. That's my suggestion. I think one thing I've seen a lot of new software engineers get really hung up on is actually feeling like they need to understand everything before they can get started. And that's just, in large code bases, that's just not tractable. You'll never be able to do everything there. It's the least I could do for them, put out the dramas of me getting to this point. Hamslab says, I'm curious about your shirt. It looks cool, but I can't figure out what it is. Well, let me step back. I'll show you my shirt. This is a local band. Smokey Brights is a local Seattle band here. So it's a foot with a rose underneath it. And then I don't actually know what this is. But it's a local band's t-shirt. They actually played at our wedding reception, which was really fun. I'm sure Adafruit would be happy to stock the S3 boards. It's just the supply chain is so limited right now. I totally get it. And I should point out, talking about the compiler stuff for Mark, Bruce S linked to a page in MicroPython where they talk about the compiler itself. So yeah, I mean, generally we rely on MicroPython to do a lot of that, those changes. David posted a link to Smokey Brights. Yeah, I'm huge fans of theirs. I've followed them for years. So one thing that my partner and I are trying to do is trying to figure out how to support local. And one way to support local bands is to buy their merch. So she's gotten me a lot of different local t-shirts from like local music venues and local bands. Thomas says, regarding 5881, thank you for an example of how to use DeviceInfoService for connections. Can now start coding for connecting only to the currently desired central connections. In the future would be desirable, but enhancing the ability to find out more about the centrals behind the connections in the future would be desirable. No need for now to go into more details of this right now. Yeah, I was starting to dig more into the BLE stuff just for this Nimble thing, and it's actually not super clear to me how to get the MAC address of the connection on the underlying stuff. There's some complexity around that because in order to be private, the numbers, the identification numbers that get broadcast in BLE actually rotate if you have it set up to do that, which you should. That's one way, so that it makes it harder to like follow a device if the device is changing its identifier from time to time. And then there will be cryptography that other devices can use to determine who's actually talking. So it's not... I've been keeping an eye out when I've been digging in this stuff to see if we can figure out what the identifier of the connection you're connected to is, but I haven't stumbled across it yet. I always think that deep diving with Scott is the perfect Monday activity to make us all happy. My Mondays are usually pretty busy. I like ordering from DigiKey too. I tend to buy a lot of stuff that's not super urgent from DigiKey. If I need it urgently, I actually get it from Adafruit because they'll pay for the shipping. S3 boards ordered. Nice. Yeah, I'm very interested in the S3. We'll see. I've made some progress. I've just been chatting. I did have some idea what I wanted to talk about today. So first, I just want to do a quick talk about CircuitPython 2022. And we've talked about this the last few weeks, and I shut it down at the end of January and did a final post. Hey, Maiko. But I actually got another one today, and since the stream last week, I also got notes from Kattni. So I thought it would be, you meant Friday. I thought it would just be cool to just, I think it's worth just touching on these things here. So let's go to, nice. People are purchasing from Unexpected Maker. That's awesome. Way to support the maker community. So here's the desktop. Let me scooch this window down. Pierre says, hi Scott, not entirely surprised the NRF52 chips in soft device have default MAC address but can be changed really easily. I think we're talking more about the MAC address of what you're connected to and not your own MAC address. You can spam the channel with S3 board stuff, that's fine. We're talking about S3s today. It's related. Okay, so I just wanted to briefly cover, I think it's only these last two that we haven't covered yet. Do we do Go Little Dog? Async support, FIDO, USB stuff. The WPA3 should be pretty easy. I think it's just a setting, but I don't really know. HomeKit I think is complicated, and Redis I'm not so sure. Let's see, that was posted Friday of last week, so maybe we didn't talk about it. It's all good. I'm fine with it. I got this one today from Axel. It's talking about having memory allocation issues, and it turned out that it's actually on the M4 boards on the PyPortal and RGB matrix. So they're taking like two rather large projects and trying to mash them together. That is running out of RAM and doing having some crash problems, which is like, it's really tough. It's really tough when, where was it? Using the ladder, it crashes after a few days. Like any crash that takes a few days to happen is just so hard to debug, right? Like crashes that are so intermittent and unclear kind of what led up to the crash is just like really, you can spend a ton of time trying to fix those because it's so difficult. Bad Abby asks, does Adafruit have any plans to support a 5 gigahertz Wi-Fi chip? I don't know. I don't do as much on the hardware development side. I think it's just a matter of like, I don't know of any chips that support 5 gigahertz. Do you? I just don't actually know what's out there for those. I know that Espressif did announce at one point the ESP32-C6, which is a Wi-Fi 6 capable. It's not available yet, but it's Wi-Fi 6 capable. But I don't know if that's, it's still only 2.4 gigahertz, not 5 gigahertz. So I don't know of any plans. We're focused pretty much on this on the S3 right now. It's kind of at least what I'm working on. So the last thing I wanted to highlight for the CircuitPython 22 is Kattni's post. So if folks aren't aware of Kattni, so Kattni works for Adafruit, has worked for Adafruit for 5 years or 4 or 5 years, like came into the project pretty early, and has this really strong, really good at writing very beginner-friendly tutorials and documentation, and is really good at getting people unblocked and leveling people up. So Kattni's done an amazing job building the CircuitPython community, which is important to highlight. And it's important to talk, like, so much of these deep dives are about the technical side, but there's no way that CircuitPython will be what it is without community, right? Like, this deep dive is part of the community, but there's just so much other stuff to do in an open source project to make it successful. So Kattni is a key part of that, and I wanted to highlight that. Oh, and we summoned Kattni. So yeah, if you don't know who Kattni's awesome. And so I wanted to take the time. She got me her CircuitPython 2022 at the start of this week, and so I just wanted to highlight it, even though it's not. Yeah, it's a lot. It's a lot of awesome community work. So let's just go over this. Maybe I'll drop the link. So Kattni just posted to the Adafruit blog itself. We're confusing Kattni. Okay, so... Oh yeah, and the other thing I should say is if you've ever seen the code plus community equals CircuitPython moniker, that was directly Kattni's idea. So Kattni is the source of all of that. So that's great. And Kattni's done a lot of revisions with our moderators on our code of conduct, and then I think they were just saying that they joined a photography Discord that like uses our code of conduct for Discord as well. So it's like it's very cool to start to see, like, the Kattni in particular has put a lot of work into the code of conduct, and to see other people adopt it is awesome. So okay, so let's go over here. So successes. We should keep the community in mind in everything we do, and I think generally we do. She says that we do a pretty good job. I can say that this has been a success. Includes awareness when designing and updating APIs. So for example, one change that Kattni's made to the core is Kattni went through and made sure that when you print out a pin in CircuitPython, if there's multiple names for the pin, the first one is the one that ends up getting printed. So Kattni went in and made sure that, like, all of that ordering was correct, so that the one that got printed was the thing that you see on the board itself. So lots of details like that make up the experience that we've got going here. The documentation and support needs have regularly been discussed in applicable pull requests, and we have had consistent follow-through. Yeah. Probably has the most CircuitPython-y post of CircuitPython 2022. Yeah, and I think it's important to also remember that, like, the beauty of having a community is that people complement each other. So, like, Kattni's a great complement to what I do and what I don't do. So I think that's a large part of it that is important to realize. It's important to realize that a community can run a project, and you know, in the same way that when we do our meetings on Mondays and we do hug reports, like no single person of us needs to know everything that is worth thanking people for in hug reports, but collectively we can shine the light on other people on the stuff that other folks are doing. So there's a huge strength in having a strong community. So okay, so room for improvement in the last couple years. One thing she pointed out last year and still wants us to continue is like we do this annual planning. Hi, Aza. We do this annual planning with CircuitPython 21, 22, but Kattni thinks that it's something that we should kind of be more open to, and we should be more explicit about throughout the year. So I did say that in my wrap-up post of like, it's never too late to let us know what you're interested in. But I think maybe we should be more explicit, maybe with major releases or releases. Compliments and compliments. So yeah, that's a good point, and I think we need to do that, is like talk about how we're always open to hear what people want to do. That doesn't mean we prioritize what people want to do, but I think it's really helpful, and I've talked about this with CircuitPython 22, is that it's really helpful to just say, hey, I'm interested in this thing, and then we have spaces where people can collaborate to make those things a reality, right? And one thing that I've always tried to do myself is that like I always prioritize unblocking people above any of the technical work that I'm doing, right? Like I do emails and I do reviews every day. And if folks have questions on Discord, I'll get those every day, every work day. So it's really important to me that like people don't get hung up, and that like as people come along and want to do stuff, they can do that. So I think we should be more, I agree with Kattni that we should be more inviting to like facilitate people saying what they'd like to see in CircuitPython, and finding the spaces and the people to work with on those things. Okay, so let's see, this second paragraph is talking about keeping up with issues and pull requests, and this goes very much into what I was just saying of like, it's no fun as a new contributor to like create something and then let it languish and not actually see it be contributed to the greater good, right? Like the main project. So that's kind of what's been still a bit of a struggle throughout last year, but it's been getting better. JP Constantinow says, I was reminded recently about the proverb, it takes a village, and CircuitPython is no different. 100%. But it is really like a shift. Like it's sometimes really tricky to recognize that it's worth the time, right? Like it can be really hard to believe that it's worth spending an hour and a half on emails every day and forum posts and things. Okay, so let's see. Looking ahead to 2022, it is incredibly important to build up those around you. That's been great. Kattni's been mentoring folks. We as admins and moderators strive to keep the community space safe and welcoming. However, the fact of the matter is that the community does most of the work for us. Yeah, that's been awesome. It's been great to be able to rely on other folks and the team that we have for moderation. When we first started the Discord, it was really me like trying to read everything, but we quickly got kind of people going. Oh, nice. Hams Lab says, I started an EFF group here in Buffalo and used that code of conduct. Hello, Johnny. Okay, let's keep going. 3 helper roles for the Adafruit Discord as a way for folks to level up, and the meeting is public. We have hug reports. So this section here is pointing out that Hug Reports is actually still limited to the people that are able to make the Monday meetings, and Kattni is saying here that we should make more of an effort to put Hug Reports in the Hug Reports Discord channel, because it's kind of an asynchronous way of doing it. We can just kind of like do it all through the week and include people that can't make it to the voice meeting. So I think that's a good point. Yeah, good first issues. Good first issues, and then also highlighting the new folks that we get contributing every week. It's been pretty awesome. Like, we keep track of like how many people are involved in filing issues and how many authors we have, and that number is going up, which is good. Show and tell is a great way to see what folks are doing. The community bundle is really taken off. It languished for a little while, but it's definitely taken off. And then for 22, Foamy Guy is going to be able to spend more hours working on Adafruit stuff, because we're paying Foamy Guy part-time, which is super exciting. And Tim, who's Foamy Guy, has already like really made a dent in the backlog of library PRs. So that's been really awesome. And like I said, the plan is for Tim to take this time slot when I'm out on paternity leave. Then Kattni says thanks to Anne and Tim and Bruce for the graphics, and thank you to the moderators, Adafruit, Lamore, and PT. And then says, we say code plus community equals CircuitPython. The more both CircuitPython and the community grow and evolve, the more true the aphorism becomes. I want us to continue to remember that CircuitPython requires this community. More importantly, I hope we can properly express to the community what their importance to us and CircuitPython. Thank you to everyone for being a part of it. I'm excited to see what happens next. So thank you to Kattni for reminding us all of the different components that go into building the community that we have. And thank you to Kattni for her hard work, and also all of you as being a part of that. Okay, let me get caught up on the chat here. So Aza says, anyone successfully using PlatformIO, VS Code, Wintel to build and upload Arduino or IDF to the Adafruit QT ESP32-S2? That I don't know. Do not know PlatformIO. MD Robert says, how does the CircuitPython 2022 resolve? Are you going to publish a manifesto or something? So I think I did try to do that in previous years, but it's tricky. And this is the line that we try to walk a lot, right? Like, there's a difference between CircuitPython prioritization as the larger project, which is made up of a lot of volunteers, and then there's also the prioritization of the folks that Adafruit pays to work on CircuitPython, and I'm one of those people. So I did kind of want to, I think in the past, not last year, but maybe the year before that even, like I did try to kind of summarize everything, but it's really hard. And I think instead, this is all I was planning on doing, is saying like, okay, here's all of them. And the way that I see it is it's really just a like, hey, check them all out. And I cover them as well, right? So like, it's more about let's all talk about it and find the people that we relate to and collaborate. And so I don't plan on doing kind of one summarization, all of that. Part of it's just I'm not a spectacular writer. And I also don't want to, like, I don't feel like I can impose on other people what they should be working on either, right? Like, I consider myself to be kind of the leader of CircuitPython core, but it's kind of really just like, I want us to all, like, the same way that we have hug reports, it's important for us to build and communicate about shared values. But I don't necessarily think that that needs to be in like one formal document. Rather, it's like a bunch of people contributing their perspectives on it. But maybe that's also just my cop-out. I don't know. I think the other piece of this annual planning that we do, the CircuitPython 22, is it really does highlight, and this has kind of been my theme as I've gone through it this month, is like, it really does highlight the principles of what is important to those of us that have been involved for a number of years, and like the things that we hold core to, like the way that we make decisions, doesn't necessarily change from year to year. And it's just cool to see how those principles and philosophies have just informed what we've done, and how successful those things that we choose to do are. I think generally we make pretty good decisions in terms of what we're going to focus on and how we balance trade-offs. So I think we're going the right direction. I think it's just a matter of like, it can get hard to go in the same direction for a lot of years if you think you're done. But I think it's important to remember that things are really quite hard still. So I think there's more room than we think there is, which is different from the like idea that that you can get bored of doing things. But yeah. Thomas has a question. I asked on Discord, but nobody seems to know the answer. Does anyone know about a driver for Windows to make a Bluetooth COM port to the Adafruit BLE services Nordic UARTService accessible by standard Windows operating calls? The Bluetooth 2x, 3x SPP serial port profile is supported out of the box in Windows, but Nordic's UART seems not to be. Yeah, that I don't know. I don't use Windows regularly, so that's part of it. But if any Windows folks out there know how to do UART over BLE, reach out to Thomas. And Paul points out that Kattni will be the first guest on Paul's new CircuitPython Show podcast. Tammy says, the principles and values of the community and of Adafruit's culture are, I think, the secret sauce of the community piece of CircuitPython. And then Pierre asks, when is the first CircuitPython Show podcast scheduled to be out? And Paul says March 1st. And thank you to Paul for doing that. I should say that Paul and I recorded our episode already, and it will hopefully be good. Should be good, but I think Paul is thinking I'm going to be the 6th episode, so it'll be a little while. I might be on paternity leave when that comes out, but I'm sure it'll be good. Okay. Any other questions, or should we dive into some Bluetooth? I'll show you where I'm at. I'll take a cat break here. Do I need like cat break music? Spook all on his own. All right, I see no questions and no objections to doing some Bluetooth stuff. I know there's a bit of a lag. Ooh. Sorry if I made you yawn. So what I've been working on and honestly struggling a little bit with is, I'm trying to remember where I was last week. So there's these like 2 roles pre-connection for Bluetooth. Can you hear my fan spinning up? I don't know why it is. So there's the central role and the peripheral role. And then there's also the broadcaster and observer roles as well. Yeah, this is what he does all day. He just sleeps. So I was initially really confused with all the different terminology from, we have palms in Seattle. We do. I was not pleased about it. But yeah, you're right. This is they have like hardy palms. They can handle like some cold temperatures. And they put them... Oh, Unexpected Maker's got to go get a flux pen. You've got an hour and 20 minutes or so. I think we'll get... I need to get some BLE work done, so we'll do that after this cat break. So, let's see. Let's switch back to the desktop. Yeah, so, or maybe I should do this. So there's kind of the process of Bluetooth is you have two devices. One of them that's off the screen. One of them is like broadcasting out, hey, I'm this, here's some information about me. And it's like not encrypted. Everybody can see what that information is, although the data itself could be encrypted. And then you have another device that can be listening for that. And that process is kind of like the thing broadcasting is the broadcaster, and then there's the observer. Are you linking to me from the notes doc from last week? Where I was last week. All right, let's see. Hello. 9:58. Let's see, what did we talk about? Desktop. Good morning. Threading, MQTT, adding the BLE. Wait, no, this isn't last week. We're missing one. We're missing the 28th. There's been a bug. You might be able to get the transcripts from the YouTube API. Anyway, so I think I did scanning and advertising. And then, so that's the broadcasting and the listening. And then the next step after that is initiating a connection. And so what I did manage to do is I got it so that it could advertise and then connect and then disconnect. And, but that was only me connecting to it instead of it connecting, or my phone connecting to my test device. Rather than the reverse. So there's like the person that broadcasts and the person that scans, and then the person that scans is typically the person that initiates the connection, and that's known as the central, and then the person that they're connecting to is known as the peripheral role. And then once you've established that connection, there's a process to discover the services that each side presents. So for example, like an iPhone will present you with the DeviceInfoService, the current time service that allows the other device, regardless of whether it's central or peripheral, to request information from the other device. Which I guess is kind of hard to understand. So let me just get into the actual stuff. So if you look in the Adafruit CircuitPython BLE repo, there's an examples folder, and there's these two, the things that I was trying to do. Well, I added a couple new ones. For Thomas, I added this DeviceInfoService. So this allows you to just do this generic advertisement and then print out once you're connected to something, printing out the manufacturer and the model of the thing that connected to you. So it's the peripheral role because it's advertising, and then it's the client of the DeviceInfoService on the other device, which is the server. So there's a lot of different terminology. It does make sense, but it took me a long time to kind of get over that hurdle. So I added that one, and then I added just like this other simple advertising test that doesn't require any of the services stuff to work. And so the next thing I was looking at getting working on the S3 is this, is there a battery service available to, we can see. So in here we have Adafruit BLE, and then we have services and standard device info HID, but I don't think, oh yeah, here's battery service. So if it's in this dunder init, that means it's kind of like you import the name of the folder and then you'll get it automatically. And one thing that I did that's kind of weird, but I'm still pretty happy with it, is I used a very declarative form of Python. So there's this object battery service, and you say like, oh, there's a uint8 characteristic on it that has the max value 100. You can read it and you can notify. So maybe this is what we should talk about today, because I don't think I've done a good job explaining it, and somebody was telling me I should write a guide for it, and I'm not a huge guide writer, but maybe covering this is a good plan. And it matches with how I titled it. So there's two main terms or things that, or specifications that they'll talk about for BLE, Bluetooth Low Energy. GAP, and GAP is the thing that manages advertising and stuff and connecting. And then there's higher level stuff that is GATT, which is the attribute stuff. And we did talk about this last week because I remember asking what they stood for. So this library is really building on top of GATT. So GATT is the process of providing services to the other device that you're connected to, or other devices you're connected to. And then the reverse is being a client of the services or servers that the other devices provide. And one thing that I try to do that's kind of weird, but I think I did manage to do, is make it so that you can have one object be kind of both. So what does that mean? So if you are let's just use the examples as the, so if we look in the examples, you'll see that there's two UART things. So UART is typically, it's a very basic serial link to and from, or like bidirectional serial link. So you just say, write this, and then the other side can read that data. And so we've got two things here. We've got a client. So this is I'm not running the service on myself, but I'm talking to it remotely. And so the way that works is you say, oh, if I'm connected to something, and what you can do with this library is you can say, if the service is in the connection, and then this is Python fanciness. So this is known as a comprehension. So I think it's better to read it kind of like this. So for every connection in our connections, do this thing, which is check for a UART service in the connection. Hello, mate. 507. And then it runs an any call. So if any of those are true, then it will be true as well. And then if that's true, we're connected to something that provides the service. Now we try to find the connection that actually provides us the service. And then this is how we get an instance of a UARTService class. that represents the service on the other device. So we say, within the connection, give us the UARTService. And then what we can do is now treat it like a UART. So we can write to it the words or the characters echo, and then we read each of the bytes back and print them out. And then we loop around and do the same thing. So we sleep, and then we do an echo again. So what you should be doing is you should say echo, and then from the other device get echo back. If you're not connected to something, now you've got to start scanning to find a device that says that it provides the UART service. So that's what this is doing. Omut says, hey there, can you point me to a CircuitPython joystick hit example that uses analog inputs for the Pi Pico? I don't know if we have one. The place I would start is the USB HID custom. This guide, customizing USB devices in CircuitPython. There's an HID one. It talks about consumer control, custom HID devices, and joysticks are gamepads, I think. So the gamepad is the one that you want. The other thing to look at is like click into the library, and just like we're browsing the examples there, for the HID one, you could do this like gamepad example. There's a move joysticks. So what you'll do is you would do like an analog read and then say move joysticks between those numbers. I don't know of a guide that specifically does what you're asking. But that's where I would start. And then the other place to start is if you don't know how to read analog stuff, you can start with the Getting Started with Raspberry Pi Pico guide, which has some examples. And maybe the potentiometer will tell you how to read, because a joystick is basically a potentiometer. So you kind of need to mix those two things. And if you have trouble, the Discord's the place to go. So the chat above me is the Discord server. You can go to that by going to adafruit.it/discord. And there's lots of helpful people that can get you unstuck if need be. Okay, so going back to Bluetooth. So this is the client side of interacting with the service. And then on the server side, this is what it looks like. So you just create the object, and it's the same object that does both things, but the way that you create it or get it dictates whether it's like a local or remote. But it's like the same definition of the characteristics, which has some trickiness underneath the hood, but I think it's actually quite cool once you learn how to do it, is that you just declare the characteristics in your service, and then you've got both your client code and your host code. So here's what it looks like on the local server side. So you're serving the UARTService. Lots of terms. So you create a provide services advertisement. This is a way to say, hey, I provide this service to everybody that's around you. You don't care who connects to you. And then so you start advertising that, and then you just wait for somebody to connect to you. And then once somebody's connected, or while somebody's connected, you read a byte. If there is a byte there, then you print it, and then you write it back to them. So it's echoing it. So pretty simple. I think this is the simpler of the two things. But that's kind of like both perspectives of using kind of services over BLE. Turns out that this part is making this side work is actually going to be kind of hard, unfortunately. And it's hanging me up on this work that I'm doing. And the reason that it's hard is because a lot of Bluetooth stacks, including Nimble, are really designed so that it's just designed around the idea that you know all of the services that you're going to do up front before you start up everything. But that isn't the case for CircuitPython, because you could actually have Bluetooth running when you actually get to this point already, particularly with the BLE workflow, where CircuitPython has its own BLE services that it makes available so that you can see the serial output and also so that you can edit the files. So there's going to be those two services already, plus there's two other standard services that are basically required. So you're actually going to, when this code starts, you're going to have 4 services probably running already. And the thing that some stacks don't do, and what Nimble doesn't allow for, is that this UARTService instantiation is adding a service that we want to provide. And the Nordic soft device that we use on NRF52 is okay with us adding services, as long as when we add them kind of all in order. And we should talk about what makes up a service. I don't know if we probably talked about this before when I did BLE workflow, but I don't remember. We can recap it. Thanks, Pierre. Have a good one. Have a good weekend. Yeah, so what makes up a service? Let's talk a little bit about that. A service is kind of like a collection. So the primary thing that you're reading and writing are what are known as characteristics. And I think of characteristics as kind of like fields, where they're just like some particular state. So at the simplest level, Pierre was talking about like the BatteryService or the DeviceInfoService. It's really straightforward, right? Like the two fields that you're talking about are manufacturer and model number, and those are just characteristics. Those are characteristics of this service, and they're characteristics of the device and within the category of kind of like the service. So that is pretty straightforward. That mental model of just like, there's a value there, you might be able to read it, you might be able to write it. That's pretty straightforward. Where it gets trickier and trickier is that things like the UART example, where it's not really that you have like values that you have state for, but rather like a stream, like a continuous stream of values. And that's where the model that they went with all this GATT stuff, kind of, it gets weird. So what happens is that there's some complexity around characteristics where not only can you read and write them, but you can also like decide to listen to when the values change. So you can say like, hey server, I'm a client of yours and I would like you to notify me whenever it changes, versus me having to ask you constantly whether it changed. And where is serial number? It is documented. So yeah, that's getting into a little trickiness. So there are optional characteristics on these services. And so if you look at the implementation and the thing that would cause it to be documented, if we go into services, standard, device info, we'll see that there's actually there's more fields than just the 2 that I'm printing off. But the reason the example only has those 2 is because that's what iPhone provides. So because these are optional characteristics, the version of the DeviceInfoService just on the iPhone doesn't have it. So if we actually look at bluetooth.org, we might be able to find the specification here for DeviceInfoService. Device Information Service. So let's click that. Let's take a look at it. It's pretty good. There's a pretty good amount of stuff that is documented. You can see the people that like came up with this. It's interesting. There's nobody from Apple there. Nothing like reading specs. Yeah, so the service is a primary service, and then there's these UUIDs, which are, what are they? Universally unique identifiers, maybe? That's what it means. Basically, they're big, long numbers that are meant to be unique to identify a service. And then there's also UUIDs for characteristics and descriptors as well. So descriptors are like state on characteristics, which is probably the clearest example or the simplest example is you can have a descriptor for a characteristic that is like a user-friendly description of what it is. Like there's a user description characteristic that you can add to all of. There's a user description descriptor that can go on a characteristic so that you can discover it dynamically. And that's really the thing about where it is. So so the device information service may expose one or more of the characteristics shown. It's possible that none of the characteristics below are included. And you can't have multiple copies of them. So just because it's documented doesn't mean that the server that you're connecting to actually presents it. And what you'll find is that if you add serial number to that example, it says that it's unable to find it or something. So because the server stuff is really hard, what I've been working on is the client stuff. So the client stuff is the UART client example is what I've been working on. And I made some pretty good progress. So let's show it off. So what pieces are actually happening here? So first, what really happens is we don't have a connection. So this bit happens second. Let me make it bigger in case folks are actually watching. I know people are listening, but I don't know if you're looking. So the thing that happens first is really this part of scanning. So what you do is you initiate a scan and say, hey, I'm looking for anything that's scanning that they provide any services. And then when we see an advertisement that includes that, let's skip any of them that don't have the UARTService. And then if we do find an advertisement that's some other device saying, hey, I've got this UARTService available if anybody wants it. If we find that, then we tell the BLE radio to connect to the device that matches that advertisement. So there's some identifier in the advertisement that can tell you like what other device is saying that. So the first thing that happens in this example is initiating a connection. So I've added that. Previously I allowed things to connect. I think in what's checked in, you're able to have something else connect to you, but you're not able to initiate the connection. So in the code that I did this week, you can now initiate the connection, which means that you're the central. That's the BLE term, is that you're the central device when you do that connection. So after you connect, we'd hit this connected. We'll stop the scan because we found the thing that we want to connect to. And then we'll do this connected check. So this is just making sure that we haven't disconnected for any reason. Networking's fun because things can just disappear at any moment. And then this process is actually one of the trickier things. So we list the connections. That's pretty simple. But actually determining whether a service is available in a connection or over a connection is kind of a better term for it, means that we have to do this process called service discovery. So BLE has this process to say, okay, given this connection, I want to figure out, do they have this service, or get me all the services that they make available. And so because we're doing this UARTService in connection, we know the unique ID of that service. So when we say, hey, I want to know if this other device that I'm talking to or this other device I'm connected to, I want to know if they have UARTService. They should, because they advertise that they do, but there's no guarantee, there's no reason you can't fake it out like that if you wanted to. Like those are more distinct processes than a lot of people think, I think, or at least as when I first came into BLE, my understanding was. So it's really important to think that advertising, even though there's like these IDs that are shared, like they're really separate processes. The GAP side, which is advertising and connecting, and then once you're connected, doing this sort of like discovery and interacting with servers or services. Like a service is the definition of the thing, and then when you're hosting it, you're the server, and if you're interacting with it, you're in the client role. And you'll see that in libraries. It's pretty common to have like a GATT-S versus GATT-C. So to say like this is a server thing that you're doing or a client thing that you're doing. So there's this discovery process that you can do. So you've connected, and now you want to say, do you have a UART service? So there's a discovery process, which I've implemented, and let me just show you the code. This is a deep dive after all. Shouldn't be scared to go deep. Okay, so I'm pretty happy with how object-oriented, even though C does not make it easy. I think our code's pretty well object-oriented. So we're in the connection object, so we're in ports, Espressif, BLEIO, or common-hal BLEIO connection. So this is on a per thing that we're connected to basis. And then there's this, these are callbacks. There's this, so functions that start with common-hal are things that are kind of mirrored, that are exposed in Python land. So there's a Python equivalent to this. And this is where the BLEIO library plays some tricks to convert that, hey, is this UARTService class in this object? It's going to behind the scenes call discover remote services. And it can take a service whitelist, which is a like, oh, I just care about these UUIDs essentially. So what we do is we say, okay, like we're going to run this discover remote services process, and we're going to pass in the whitelist. So that's what's above that. And so we say, oh, like if the whitelist is none, that means we just want to discover everything. So this call here is the Nimble call to get all services. And you can see here that it's got this GATT-C portion to it, which means that it's kind of like part of the GATT client API. So discovering what the other device provides over GATT. So one of the things I've been having to learn a lot about is what's really common in the Nimble API is that you give it a callback. So you give it, so this here is actually a function pointer, and then the next parameter is the object that gets passed back to you when that callback's called. So what we have to do, because we kind of expect Discover Remote Services to be blocking, meaning it does the whole process and then returns. What we have to do is we have to use the free RTOS primitives to say like, okay, I'm just going to wait until this thing's done. So that's what this take is. So take is saying like, okay, I'm going to wait until I get notified that it's my turn to, that I get notified it's done. So discover all services, we'll call this discovered service callback. And then there's a different version of this, which is if you give it a whitelist of UUIDs, it does this GATT-c discover services by UUID, and it's in a loop. But it uses the same callback as the first one. And it also has its own take. So if we scroll up, we've got discovered services callback. It gets a connection handle, the error, the service information, and the argument that we asked it to give it back to us. We check the error status. If it's any error status besides success, then we give back. So it will potentially call this callback multiple times. And the last time it calls us, it will say it's done. So there's an error there's a success error status and there's a done status, which is a little weird. But we're trying to wait until it's done. So if the error status is not success, which includes done, then and it's the first time, then we kind of finish. So we store it in a variable we can read later, and then we also start back that other task. If we just got an item, we do some allocations. So we allocate an underlying service object, and that's the service object that like the BLE library wraps in the UARTService thing. Yeah, so the service from connection creates a service object that is remote. And then the GATT stuff is like, there's a big long list of all of the services, characteristics, and descriptors that are made up, that are available. And they have these unique numbers for each of them, which are called handles. So the handles tell you like what index in that table the thing is. So when you learn about a service, you'll figure out what handle range encompasses the service. And we have the UUID of it. So we'll make an object of that as well. And then we add it to our remote service list. Going back down to discover remote services. So we've done it either one of two ways. We either discover them all or we're discovering them by UUID. It does take time. So discovering by UUID will be faster because instead of discovering that whole table, you're going to discover just the section that you care about. And I think there's like a lot of back and forth and stuff. So if the connection process or getting that the first time is slow, then you might want to try to do just the services you care about. So once you know the services and their ranges, the next step is to discover all of the characteristics. So that's what this call is doing, is discover all characteristics. Again, it's GATT client, and now you're doing it. You're saying, I want all the characteristic info for this section of the table that is all of the things for the given stream. So that's where you're using the services start handle and end handle to like narrow down what part of the table you care about. There's another callback to get that information. And then lastly, you do that again. So for every characteristic, now you get all the descriptor stuff, and that's what this is doing. And there's appropriate callbacks here for each of those things. But they're not that different. There's some like data differences between the things. Like here's properties about whether you can write or read or notify or things on different characteristics. But kind of fundamentally what services, characteristics, and descriptors are doing is they're creating the objects for you to use later. Even though the objects have like slightly different data in them. So once you've done that, now we're back up at the common-hal. We create a new tuple and we put it back. Patrick says, missing show notes are live in the repo, and maybe I fixed the bug with adding the thumbnails that was breaking the action. Nice. Thank you for doing that. All right, well, that's the weeds. But this is something that I got working. And so once you're able to discover the service and creating all those objects, now you can use them. And so I've been working, you can see here, I've been working in characteristic a bit. I think I'd actually written some of this code before, but I hadn't tested it. So now I was able to write stuff. So we got 45 minutes. Let me actually run the example code. So I've got two things here on my desk that you won't be able to see, but I'll tell you what they are. So first I have, whoa, that camera's closer than it used to be. This is an NRF52840 board, our Feather, and on this side you can see here that's kind of got this similar like module on this. So this is the first chip that we supported with BLE. And so what I have here is some code running the UART test, so the server side of the UART stuff. So I'm going to plug that in on my desk here, and I basically just leave that running as something that I can connect to from the ESP. And it actually pops up, and I'm going to just mount it and then eject it because I don't actually care about it. And then I've got this, I'm making sure it's the right one. So I've got this ESP32-S3 board, and it's got the client UART code on it, so that it can connect to the NRF and try to do the echo test, which Dan pointed out to me when I was talking to him. He's like, a lot of our examples do GATT client stuff. So like, if you ever seen like a Bluetooth thermometer that you're connecting to, like that's all GATT client. It's not GATT server. Unfortunately, the BLE workflow stuff is all GATT server stuff. So once I've finished this stuff up, then I will be moving on next week into the server world. Okay, so let me pull up this. I've got this lovely set of four things here, and I'm trying to remember how I had them set up. So this one I think I had set up as dev serial by ID USB Adafruit. So this will be, the top right will be the serial output from the NRF board, and you can see here it is getting echoes. And then I wanted to do over here the USB serial connection to the S3 board. So if we connect to that, we can see that we are printing out. Welcome back, Unexpected Maker. I got deeper into GATT service discovery stuff, and now I'm showing you where I'm at on this demo. Lots of weeds in BLE land, yeah. Okay, so this is what's happening, is that we've discovered the services and characteristics. We're writing, let's go back to our example, which is here. So when we're talking about here, we've discovered the service, so this is true. We've found it true again here, or yeah, and then we've been able to get it out. And when we call write, we can see that the word echo is getting to the NRF, and then what this is actually telling us is that it's getting back to us on the ESP side, but we're not doing the right thing with it. So that's what this unhandled connection event is that there's an event that's coming back into a callback from Nimble that we're not handling. So if we go back to our example code, we've done this successfully, but this read is not working. That read is not reading the data. And the reason that is, let's stay in these BLE weeds because they're not super clear. So how does the read work? How does UARTService actually work? So let's take a look at that. And I'm going to open it in a separate window, or a separate tab. So in Adafruit BLE, we have services, and let's look, it's under Nordic. So Nordic are the folks that have kind of defined this kind of standard UART service. You'll also see it abbreviated as NUS for Nordic UARTService. So it provides UART-like functionality via the Nordic UARTService. And our goal is that this API looks like busIO UART, right? So there's two fundamental things that so here's, if it's not a standard BLE UUID, they tend to be really long. So this is the standard unique ID for the service itself. That's what the UUID member is. And then we have two internal characteristics that we're talking about, one that does transmission and one that does receive. And you can see that they have different UUIDs as well, and we are defining buffer sizes. So then we have to do a little fancy stuff here. Some tricks under the hood. So if you initialize UARTService, if you pass in a service object, like a lower level service object, we'll pass that up. And then what we actually do is we flip which one we're talking about, depending on whether we're the service itself or not. So that's what this is doing here. And we call ourselves connectable to, which I don't know why that's there. That seems weird. That's an advertising thing. So how read does is read just reads from the RX. Read into reads from RX. And read line RX in waiting, reset buffer, and then writes to TX. So we have StreamIn and StreamOut, and they actually get, these are related. The TX and RX are names for the server side. So like if you're not the server, or yeah, you swap them at some point. Like it's UART. You don't, I'm always confused about how you swap them. When in doubt, swap them. So let's take a look at StreamIn and StreamOut. And their characteristics. So we're going to look in characteristics, and there's stream. So this is where I play some tricks, some Python tricks. So these are both complex characteristics. So what complex characteristics are they're kind of like, I think of them kind of as placeholders. So at some point, when you define the service, you'll say server tx equals this stream out. But what happens is that when it actually starts getting connected, it gets replaced. So that object actually doesn't stay there. Instead, it gets replaced by what it gets bound to. So this initialization of StreamOut happens before the service object is actually created, because it's a data descriptor, which means it's kind of like outside a function. This is deep Python stuff, but it's all in service of being very declarative at the outer level. So holding on to some settings, and then complex characteristics have this bind thing. So you can say, hey, I have this service object, bind to it, and then it can do that at the top level, and then we have some specific stuff that we do. If the service is remote, meaning that we're the client, then we use characteristic buffer to, right. So this is stream out of the server. So if we are remote, there's stuff coming from the server to us, and we have to buffer it. Otherwise, we have bound write stream, which goes the other direction. And then stream in is going to be very similar. It's just going to do the reverse. It does bound write stream if we're remote, and if we're not, then we have to buffer incoming stuff. So they both rely on this characteristic buffer, which is actually a native primitive for BLEIO. And then bound write stream is like this object that gets replaced, and it just has this write call, and it just writes to the characteristic there. One thing that write could do to make UART faster is actually it could, if you wrote multiple times small things, it could like actually piece those together to put those together into packets, but it doesn't. So I think I've covered all of the Python-y stuff, and there's definitely tricks here into how this works, where it like gets replaced and things. But it seems to work pretty well. And it does make it very declarative, which is cool. I guess I didn't talk about the superclasses, but I don't want to get into those weeds right now because we have 35 minutes to fix this demo. So we have characteristic buffer, and what does it have? So we can construct it. We can either construct it like dynamically, where we're allocating memory, or we have a version that takes the memory in case we want to initialize it without dynamic memory, which is very useful for the CircuitPython BLE workflow stuff. So we can statically allocate a characteristic buffer for the UART service that we provide as part of like core BLE workflow. And then we provide read and how many characters and things are in our buffer and whether we're connected. So it's like not too complicated, although this is not the full implementation. So this is the Espressif version, and you can see kind of that there's a lot of this ring buff stuff. So ring buffer is a memory area that you're like writing values in, and when you get to the end of it, you'll start putting them at the start. So you're kind of like keeping a sequence of values together, but that sequence can wrap around, hence the term kind of ring. So we kind of have a standard ring buffer implementation for that. And that's what buffer size is all about too. So this is the thing that doesn't work. It's not actually putting the bytes that we're receiving. So the way that the bytes come out of a Nordic UART service is that it happens through notify. So this is the, hey, I'm a client, you're a server. I'm not going to keep asking you whether this value changed, just tell me when it changed. And that's what there's two mechanics to do that. There's notify, which is like, hey, let me know that this happened. And there's also indicate. And indicate is like, hey, not only should you tell me that this happened, but you should require me to tell you I heard that. Keith EE says not too complicated. This is a deep dive, true deep dive. Yeah, we're getting pretty deep, but that's what it's all about, right? If you have questions, please ask them. If I'm skipping over important bits, please ask. I'm happy to take a step back and try to explain what I'm doing. So I do think this is an interesting design choice from the BLE side of having these two terms for notify and indicate in one direction, when there's also kind of like the corresponding sort of commands going the other direction. So there's two ways to write to a characteristic. So I'm a client and I want the server to have this, I want to have this value, and there's two ways to do that. I can do write and I can do write without response. So Bruce S was up too early and hasn't had a nap yet. So write is just like indicate. It says, I'm going to write you this value and you have to let me know that you got it back. Whereas write without response can say, hey, I'm going to write this value and you have to tell me, or you don't have to tell me that you got it. And the other piece is that there could be a long time between like when you write, like milliseconds between when you write and when you hear back. And so it's much quicker to do the write without response stuff. Both write without response and notify can be a lot quicker than the ones where you're required to wait. But yeah, it's understandably tricky. It took me a long time. Like, the only reason I have this good of an understanding is because I've done it before, which is also why it's kind of hard for me to want to work on it again. Is like, I've been there, not learning a lot. Bluetooth is tedious. Yeah. We haven't even talked about any of the security stuff yet. And the state that you're supposed to store with that. We'll get there, maybe. Or I'll hand it off to Dan. Hopefully I can at least do the server stuff. Who implements the security stuff? We did. Well, that was one of the things I was doing with the BLE workflow, is getting the security stuff kind of on by default. BLE has a lot of moving parts. Yep, I agree with you. A lot of what I've been thinking about is also trying to kind of figure out what our long-term BLE plan is, because we have the Nordic soft device, but the soft device in Nordic is actually closed source. Like, you can't look at it. It's just a binary blob. And so I think what I'd really like to see is like a version of like a Bluetooth stack that is very similar to Tiny USB, where it's just like we have one Bluetooth stack and we use it for everything. We use it for everything that has BLE in the same way that we use Tiny USB for all of our USB stuff. So that, like, my long-term goal is like, I'd love to see us just use this one BLE stack for everything. And that could be really cool too for the Nordic chips, is because we've talked about the NRF5340, which is the newer NRF chips. And that's not supported by a soft device. It's supported by Zephyr, but there's also, it's also supported, I think it's supported by Nimble as well. So Nimble could be the way that we go, just like, this is the stack we're always going to use. How do we go about building CircuitPython? You have 2 files for boards that aren't in the download list. If they aren't in the download list, that probably means that they don't have a board definition, which is pretty easy to do. There's 2 tutorials that will get you started, and as always, the Discord's a great place to get help. But if we don't support the board, you'll need to add a board definition. So here's the tutorial on how to build CircuitPython, and then there's also a tutorial to how to add a new board. It's faster for me to search my browser history than to find it on Learn. So between those 2 things, that should be able to, you should be able to add it, and then please submit it and we'll get it on the downloads list. That would be awesome. So I'm not familiar with Tiny USB. Is the BLE workflow moving to be Tiny USB but over Bluetooth, not USB? No, Tiny USB is more, Tiny USB is not workflow specific. In the same way that Bluetooth has this BLE stuff that we're talking about has layers, like USB has layers as well. So like USB has this lower level link layer, which is what they call it. The BLE also has a link layer. And then kind of on top of that link layer, there's this standard, it's almost like services like we were just talking about, right? Like, but what's the term? Like USB HID, USB MIDI, USB mass storage are all different classes and descriptors and stuff. So that it's very much like what is built almost on top of GATT in BLE land is also what you need for USB. So they're not, they're similar in the way that there's like protocol code that you need that sits atop kind of a standard hardware API. Whereas like the amount that you need to change chip to chip is actually not that much. In BLE land, in USB land, that's usually just like there's a few different types of packet types on the wire, and then it's all a matter of like putting those together. And there's like a pretty small API that you have to implement like on a per hardware implementation basis. But then there's also the but then there's a whole bunch of stuff that's standard that's built on top of that, and that's what TinyUSB does. And then in BLE land, there's this pretty strong API that the Bluetooth spec lays out called HCI. So there's two core components to BLE, which is the host, and then there's the controller. And the controller is the thing that's like pretty timing sensitive. And then there's an API between the controller timing sensitive stuff out into host land, and that's the HCI interface. And so the host side of that can really be, there's a standard API and that can be shared. And that's kind of what we're all talking about right now. The lower level link stuff is what the controller handles, and that is usually like something that the vendor provides, which means it's pretty easy to fit a standard host stack on top of the HCI API, ideally. Hamslab says, I'm going to set up building CircuitPython really soon. I let a friend borrow my Linux system while I fixed theirs, and for some reason things weren't good, so I just reinstalled Linux since this deep dive started. Goodness, that's a lot. Thank you for the explanation. Yeah. I'd much rather have one stack than a lot of stacks to maintain, though. I'll tell you that much. And so one thing that we've been doing is like the MicroPython folks have like 2 or 3 BLE stacks that they maintain. Maintain not the whole stack, but maintain working in MicroPython. And our philosophy has always been to like really pick one. And one of them that they use is Nimble, which is what we're using here. So we're trying to like collaborate with them on maintaining Nimble and changing it in ways that benefit both of our projects, because CircuitPython and MicroPython have common problems of being more dynamic than usually these stacks expect us to be, which is the services thing is an example of. But yeah, lots of details. Okay, so there's how to add the board stuff, and Discord's a great resource for that. There's no software engineering problem that can't be solved with another layer of abstraction. Yeah, Tammy, I've heard that too. I think that the main thing is getting the abstraction in the right places. But there's some pretty neat things, like the MicroPython folks have been using Nimble for a while, and they've actually gotten Bluetooth from MicroPython on Linux working, because on Linux you can talk HCI to like a USB dongle. So you can have a USB dongle device that's running a controller, and then over USB you can speak HCI into your host Nimble stack in MicroPython. It's it's pretty standard. The problem is that not everybody gets it exactly right, as is the case in most specs. But it's pretty standardized. Okay. So what are we thinking? Let's take a look at the implementation for the NRF version and see how it works in NRF, which I've already done, but we'll do again. And I think we're running out of time because my voice is tired. So we'll go another 20 minutes and then call it. Okay, so we're in characteristic buffer, but this time in NRF. So NRF has this write to ring buff, and then it has this characteristic buffer on BLE event. So this is similar to the callbacks that we were looking at earlier. And we can see that there's event IDs. We can see GATT S, so this is server, event write, or GATT C If we're a client, then we got HVX, which I don't know what HVX stands for, but it's basically we received a notification. So in one case, we write to the ring buffer because somebody directly wrote to us, but in the other case, we're a client and they essentially wrote back to us using that. So you can see that this use really fuzzes the idea that you have this like one single value that you actually care about. In this case, you actually care much more about just the data that you're sending back and forth. But that's the key piece that we're missing here. You can see that we're adding, did I copy this over? We might want to leave this open. So in the constructor for characteristic buffer, what we're doing is we're adding an event handler. So we're saying like, hey, like whoever manages this event handler, which is kind of a global, like, hey, call this function and give our object back to us if whenever an event happens. And then there's actually like a lot of events that flow through here that we just don't care about. They just fall into this default case. And then further down, it's all this standard ring buff stuff. So it's really just a like, all right, in the Nordic stuff, we have this event handler that gets called and then snags the data out and writes it to the ring buffer. And then we read it from the ring buffer as we need it. So that's what we need to do on the Espressif version as well. But the Nordic stuff has kind of like one event handler to rule them all. Whereas a lot of the Nimble stuff is like, if you're doing an advertisement, like you provide a callback, and when the advertising finishes for some reason, that callback gets called. There's kind of not necessarily one kind of event handler to rule them all. But there is one that gets this information about when notifications happen. Remember, we're only focusing really right now on the GATT client case because the GATT server stuff is hard for other reasons. Yeah, the GATT server stuff is hard. So what we need to do, and I think the way that I decided to do it is I just need to essentially have this event handler system to delegate handling of some events down to individual characteristic buffers, or we also have another way to buffer, which is packet buffer. Unexpected Maker says, just for clarification, this is all BLE workflow stuff you're working on right now, not just standard BLE support for the S3. I missed you starting work on this today. So this is more the latter. It's more just standard BLE support than it is workflow specific. The workflow stuff is built on top of our standard BLE APIs, so there's a lot of sharing. The one trickiness that the BLE workflow stuff adds on top of this is the fact that it needs to be able to work without doing dynamic memory allocation. So you'll see in these APIs that we've got here, we have these like underscore versions of things. And those are the versions that don't allocate memory, they take the memory in. And then we have this wrapper version that gets called from Python that does do the memory allocation. So a lot of it's shared. There's not a whole lot of difference. But the thing that is different is the fact that we do have to think about memory allocation. This is not actually working on the BLE workflow side though, because what the BLE workflow stuff needs is to be a GATT server, not a GATT client, unfortunately. And there's difficulty and harder things to do in that space, so I want to get the GATT client stuff working first, which is GATT client is all about talking to another device to get information from it. So after this gets in, you should be able to say like, oh, I found this thermometer and I want to read values off of this thermometer. I know we have scanning working in main now, so it's good to know this is continued support. Yeah, so this main currently has scanning and advertising, and you can connect to the device, but you can't initiate a connection from the device. this code has initiating that connection and discovering the services that that device has and then talking to it. Handle value notification or indication. Yeah. Right, so handle is like the numbering in the attribute table. Value is the thing it's pointing to. And like I said, notification and indication is like hearing back from a device to know that something changed. I think it should be a little bit more symmetric, but they do like having separate terms for separate things, which is generally a good policy. It's just you have to be able to describe them well, and not all the resources I've seen describe them well. All right, let's see how far we can get, because I did start this. So I've added, let's go back to Espressif. Actually, I think I want to steal this. Let's see if we have this in here already. We don't. I deleted it, which is good. So you can see that we have the same static handler entry here. And I changed the name of that. I need to figure that out. I should probably move this event stuff, some of the event stuff out so it's shared. So that the names are different. I'm gonna have a problem with that. But we can do this characteristic buffer on BLE event thing. So we need those. What I was renaming this is, I don't like abbreviations. So I renamed this to BLE event add handler. And the cool thing, so the way that the handler works is, let me pull it up. We're not going to finish this today, but, well, I might finish it after the stream, but not before the stream is ending. So the way that the event handler happens is that you can add a handler, remove a handler, which are just functions. You can add an entry, and what this allows you to do is add something to the list without causing an allocation, which is great if you're doing things statically like you do in the BLE workflow. And then the way that you store all of those things is what's called a linked list, which for any of you who are classically trained software engineers will have done lots of linked list stuff. But the basics of linked lists is that you have a struct object and it points to the next thing. So it's got a pointer to another entry. So that's what this next is. And a linked list is defined by a bunch of pointers between entries, and the last entry doesn't point to anything, it points to null. So next will be null on the last entry of that list. The advantage of doing this is that there's a couple things. One is, how do I say it? What's nice here is you can mix statically allocated stuff and not statically allocated stuff. And we also know that the statically allocated stuff will come at the end. It's also nice in that if you need to add more things, you don't need, if you have an array where you're like, everything's right next to each other, if you need to make it bigger, you potentially have to move it and copy it, and that gets really tough. But the nice thing with linked lists is that like the things that you add to it can kind of bring the memory with them, which is really convenient because, so in the case of like the characteristic buffer, in the buffer object itself, we can store its entry for that. So if we look, I'm sure it's in there. So it makes memory allocation and ownership easier to manage. Oh, it's not in there. Huh. I expected it to be. That's interesting. Maybe it should be. This add handler will allocate a separate one. Okay, so we need that, and then we need the callback. Let's just call it the same thing. Let's copy these two things. This is what I've been doing a lot of. So I take the NRF version, and I decide how I want to change it. One thing here is the right to ring buff. I don't actually think I need this. So these critical region things are making sure that something doesn't interrupt what we're doing, which then leads to memory issues. But I don't think we need that here. I don't think we can be preempted or interrupted by something. So I think what we can do here is we can just write it directly. It'll be fine. We don't have a bunch of code that we need to copy in places. It's just one call. And then the BLE event that we're dealing with is different. It's no longer a Nordic thing. Gap event function. So I actually have a second Sublime text open. So you can see this is actually the function type for this, and it gets this type of event. And so that's what this is here. And the param is the same thing. We're going to want to cast it, and then we can treat it as self. And then event here is, it has a type. And then what I've also been doing is, in default, I've been saying if CircuitPy verbose BLE, let's just print f that we got unhandled gap event. Which might be redundant. We might get a lot of those prints. But it can be kind of handy, and that's actually what we're seeing right now as well. Unhandled gap event, and then the ones that we want to support. So we're going to actually need two callbacks, because in the Nordic case we get events for both writes and notifications. But I think the callbacks that get the writes are different than the callbacks that get the notifications. So we're just going to do one side of this thing right now. And the way that we're going to figure out that is, I think, in this giant header file. So this is the struct that they give you. So there's usually like a substruct that matches the type. So like periodic transfer, scan request received. It doesn't make sense, a lot of sense to me, that this is in the gap one. It's really not a gap event. It really should be GAT level, but it's complicated, as we've all seen. So this one's interesting. So this says something subscribed to you. So if you're the server, this tells you that somebody's listening and you need to notify. So that's interesting, and that's actually how it gets really complicated if you think that, you know, UART is like you are talking to one other person, but you can actually have multiple connections, and both of those things can listen to notifications of a value. So you have to play some tricks about, like, well, if you only really want to send it to one place, you've got to kind of have a way to figure out who you send it to. Notify TX, this is saying like something finished that you did on the server. And then notify RX is if you're a client and you heard back. So this is the one we care about, and this is actually the type that matches up to it. So what it gives us is, it gives us a buffer of the raw data, a Boolean essentially to tell us if it's a notification or not, the connection handle, and the attribute handle. So what we're going to want to do here is, it's the equivalent of this, and let's delete that because we're not going to use that here. So let's do the equivalent of here. This is an anonymous struct, so I don't actually think I want to do this. I think what I want to do instead is must be a notification, and event handle must match the handle for my characteristic. So we're going to say event, and we want to know if it's a notification. So we're actually going to do notify. Oh, you can't see this other part, but that's okay. Notify rx dot indication, and we want that to be equal to 0. If it's 1, it's an indication. If it's 0, it's not. So that's the equivalent test here. And then to get the handle, we say event notify rx dot adder handle. So that's the attribute handle there. And then the data is in this OM buff. This is what I'm looking at. So I'm looking at here. This is where our data is. And this could be more complicated. Because it could be non-consecutive buffers, which is kind of annoying. And I don't know it very well. So OSM buffs are basically linked lists of buffers, which is convenient if you don't want to have to do an allocation just to merge stuff together. And that's fine. That's ring buff is copying the data, so we could do it piecemeal. We just have to figure out how to get all the pieces out of the M buff, which I don't know how to do. Make fetch submodules is taking a long time. Shouldn't be that long. It's a lot better than submodule init, which will pull down a giant GitHub repository for Raspberry Pi. You could do it selectively. Patrick says, has there been any discussion of doing BLE Mesh support? I'm not sure why I'd want that, but I'm curious if much discussion has gone on about it. I haven't seen any discussion really. Nimble does support it, so that would be a good foundation to build an API. But right now I'm focused on getting the existing BLE API that we have going. I figure we would want to do it at some point, but I also like BroadcastNet. But that's my bias. I don't know. I'm not sure I've seen a lot of people doing BLE Mesh. So if you want to add it, that'd be great. Yeah, exactly. Good community project. I mean, that's the advantage of doing something like Nimble, right? Is like we could add a BLE Mesh, we could add BLEIO and BLE Mesh APIs that were just standard. I know. I think it makes a lot of sense to have a common stack. Hamslab says it's doing a boat ton of clones. That's what fetch submodules does. We have a lot of submodules. And did we merge in the ST one? I think I did. So yeah, there's even more. We have a lot more ST ones now. All right, so the next thing that I'm gonna have to do is I'm gonna have to figure out how to split apart this OM buff stuff. And then once I can do that, I'll just add each individual buffer to the ring buffer, because there's no reason I need one giant buffer to copy it over. I almost need like a loop. I'm sure there's an example in here somewhere. Like here you can copy data out of the OM buffer. So I could look at the implementation of that. And see how they loop through it. Just do that. Copy into, concatenate, extend, pull up. I don't know what that means. Rearrange the chain so that length bytes are contiguous. I mean, I don't need to do that. All I need to do is go over through each one. So yeah, I think I want to just look at the implementation of, where was it? Copy data. If I just steal this. I don't see a way how to just say like for every mbuff do this. It is really nice that it's open source. Copy data. Apache Mynewt offers the world's first fully open source BLE stack. Compliant with Bluetooth 5. Yeah, I wish it was what people were still working on, but I think Zephyr's got a lot of folks working on it. All right, it's 4:01. My voice is tired. I'm going to try to actually get this going today. And I've got an hour before I'm playing some video games, so I'm going to wrap it up. Thank you all for joining me. Sorry if I caused you to yawn. It's been a pleasure hanging out with you. Follow along. I do push all my changes, so I'm in this ESP BLE GATT client, and it's still running. It hasn't crashed. That's good. So check out my repo. You'll see this ESP BLE GATT client. I use it as my backup, so if you ever want to see what I've been doing, check that out. Let me just pull up my notes to make sure I don't forget anything. As always, I'm sponsored by Adafruit to work on CircuitPython and do all this BLE stuff and do these streams, so please support them. They support me. You can support them by going to adafruit.com, doing some stuff there. If you want to hang out with me and everybody that you've met today through the chat, please join the Discord, adafru.it/discord. That's where we hang out all the time. There is a CircuitPython dev channel that if you're trying to build stuff, that's a great resource. If you're trying to do internal stuff, core stuff, that's a great place to start. Deep dives happen every week, probably for the next month. Probably not much more than that, at least from me. Normally Fridays at 2 p.m. Pacific. Should be true next week as well, that it'll be Friday at 2. I typically go for 2 hours or so. I haven't done the more in a while. I think I've got to talk less if I'm going to make it past 2 hours. And then thank you to Patrick and David for taking the notes and Patrick for organizing them on GitHub at github.com/adafruit/deepdive-notes. Thank you to them for doing that. Yeah, check that out if you want to go back and take a look at stuff. Next week's on Friday. Hopefully I'll get a PR out or at least make some progress on this GATT client stuff today. And I'll pet the cat and we'll get out of here. We'll see you on the Discords and streaming next week. All right, have a great weekend, everyone.